In Learning Objective D, I just want to highlight some few suggestions on when to use these various methods to solve for triangles. Step one would say if you have a right triangle, definitely go ahead and use SOHCAHTOA. It's probably going to be your best bet. But you also, whenever you can use SOHCAHTOA, odds are you could use law of sines if you prefer. That's fine. Second thing, if it's not a right triangle, they're going to consider, try doing law of sines first. One, it's an easier one to try. If you set it up and you have two unknowns, scrap it and try something else. It tends to be more useful when you have triangle relationships that look like what they're saying, angle, side, angle, for example. So if they give you this angle, this side, and this angle, law of sines will probably work. Step 3 says if law of sines doesn't work, just try law of cosines. And I think this is really good advice. Now, do take a look at this example down here. If I want you to solve for angle x, which is right here, we have a right triangle. So it looks like what would be, we have opposite and hypotenuse. So it makes sense to do the sine of x and do 3/6. And to solve it, you would just do the inverse sine, it looks like, of 1/2, and you get your answer. But could law of sines work? It could. What you can do is use this as a relationship in this. And what you would do is you would type the sine of x over 3 is equal to the sine of 90/6. To mathematically solve this, you'd multiply both sides by 3. Well, what happens when you do that is obviously these 3's go away. 3 divided by 6 becomes the 1/2. The sine of 90 is the number 1. So this actually simplifies to being the sine of x equals 1/2, which is the same thing that we were just doing over here. So it doesn't matter if you do SOHCAHTOA or law of sines. Now I want to show you two examples of how to sketch the scenarios when you're dealing with direction using north, east, south, and west. The first thing you want to do is actually just drop a compass on your paper first. And then what we're going to do is sketch the scenario right on top of it. So it says here we're at the high school and we travel 12 miles, 30 degrees east of north of the high school. So what you want to do is have your starting point be right in the middle of the compass. So let's have the high school be the starting point, and we're going to put that right here. So Mound Westonka High School. Now the key here is we're going to travel 12 miles, but how are we going to travel and what direction do we go? Here's how we have to move. We have to go 30 degrees east of the north. So what that means is that we're kind of looking north, but we move 30 degrees east of that direction. Well, if we're going north here, the east is to the right. So we're looking north, but again, 30 degrees east of the north means move 30 degrees and then travel that way. So if we do that, what's going to happen is here's how we travel. And that's the angle that got created, was at 30 degrees. Now we did go 12 miles, so I'll just put that right there. And there we are. Now the next part, your friend is directly 10 miles east of the high school. So our friend was at the high school and they went 10 miles, east of it. So we'll just do 10 miles there. And this is our friend and this is me. The question is, how far are the two of you from each other? So I need to know that right now. Now be careful when you look at this triangle. It's not drawn to scale. This looks like a right angle. I don't know if it is, and it's actually not, so do not use SOHCAHTOA. We do have this side length and this side length. There's no interior angles marked, but I can mark one of them. Be careful, this compass movement here is a 90-degree angle. Well, if that's 30, then it's easy enough for me to know that this is 60 degrees. Now we have to find this side length, so you have to think SOHCAHTOA doesn't work because it's not a right angle. Will law of sines work? Will law of cosines work? Law of sines does not work on this one, so what you're going to have to do is use this angle and this side for law of cosines, and then use the other two sides. So I'm just going to set it up, but we won't solve it. So I need side length x, so it's x squared. Remember, if I use this side, I end the formula with that angle, so I'm just going to go end it right now. Cosine of 60 degrees. And then we're going to fill in with the other two numbers of 12 and 10. So it'd be 12 squared plus 10 squared minus 2 times 12 times 10. And then I would just go ahead from what we did and solve using the law of cosines. Let's try setting up another one with some direction. So again, before I get started, I'm just going to draw the compass here and read the question. So from a specific point in a school classroom, students can see the top of a skyscraper in the city if they look. We are going 41 degrees west of the north. So let's just stop right there. So here they are at their school. Always just put the starting point right in the middle of the compass. So what are they doing? They can see the top of a skyscraper if they look 41 degrees west of the north. So they are looking, they're looking westward of the north. So they initially are going north. They're going to move west of the north. So 41 degrees west of the north means you start off north and you go 41 degrees towards the west, which means this right here is the 41 degrees. Okay, so let's continue on with the problem. So they've spotted a skyscraper though, so I'm going to actually put the skyscraper there so I can see it a little bit better. That's my building. They're then going to travel 4.1 miles due west from the school. So we're at the school. They're going to go 4.1 miles due west. And I am just going to go all the way down here. This may be not drawn to scale, but that's okay. Now it says here, the same skyscraper can be seen in the direction 26 degrees east of the north. So here we are at this blue dot. I'm going to put that compass right back on here so I can see it better. And what they're doing is as they're standing here, they are now looking 26 degrees east of the north. So here's north. They're going to go 26 degrees east of that. So what happens is this right here is the 26 degrees that gets created. And that is all they tell us for this problem. The question is how far is the school from the top of the skyscraper? So it looks like what they want to know is this side length right here. Okay, well, what do we know about this problem? I know that this is 26 degrees, but this whole thing, it makes a 90-degree angle. Well, from that, I can do 90 minus this. And if I do that, this right here is just going to become 64 degrees. Well, I also know that this one here is 41 degrees, but this is a complete right angle. That means this here has to be 49 degrees. Now, do I have enough information to find how far the school is directly from the top of the skyscraper? Sure, I have 64 degrees in that side length. The other thing that I know is this side length, and I actually know what this angle is right here. I just don't have it filled in. I can just take 180 degrees minus the 64 minus the 49 degrees, which would give me 67 degrees. So that's what actually goes right here is 67 degrees. If I set this up, what I could do is law of sines. I could say x over the sine of 64 degrees is equal to 4.1 over the sine of 67 degrees and solve.